Alright, the AC for the office ain't working, Skid. This is for the property manager's office. This is a heat pump, by the way. Goodman heat pump. They put straight cools on all the apartments and then heat pumps on the office. I see a dead lizard on the cap there. Man, if I'm gonna go, I'm gonna go in a train. I'm gonna go in something a little high class. I'm not gonna die in a Goodman. Not gonna die in a Goodman. Contactor's pulled in, so that's good. This whole unit's not coming on. Hopefully it's just the cap. I'm sitting here in a bunch of water from the irrigation, I guess. But I checked the bottom of the contactor. It's got 240 coming in, so the breaker isn't tripped. That's good. Contactor's pulled in, breaker's not tripped. I think we're just gonna have a bad capacitor. Easy peasy. I'm gonna take the capacitor out because of all this water here. I can't stand good. So I'll just pull the whole deal out. Test it over here on this table over here. Alright, set the meter to MFD for microfarads for you new guys. And between C for common and Herm should be a 45. This is a 45/5 capacitor. 22. Ooh, that's way low. And between C common and fan, .60. That's low as well. As you can see, it should be 45/5. So I'll go get a new cap, put it in. Alright, the new capacitor is mounted. Yellow to Herm. You can see it on top of the capacitor. For you new guys who are wondering, how's he know where the Herm is? It's written on top. C for common, F for fan. It's actually spelled fan, so the only one that's abbreviated would be the common, just a C. And Herm, H-E-R-M. Alright. There we go. Yellow to Herm, red and purple to common, and brown to fan. The Herm was really low at 22. Should have been 45. Come on, big money, no whammy. Well, got the new cap in. Still not coming on. I'm gonna have to step in this water here. I couldn't get around to look at this circuit board, but it's looking a little crispy right here. See how that's discolored? I think we got a bad circuit board, Broseph. I can't get around because of all this water. I couldn't see down in here, but now that I've stepped in here, I can see it. It's a little discolored there, so I'm gonna see if Johnstone's got a new one. Can't ever be a cap. Alright, Skid Bros, I went to Johnstone and got a new defrost board for that heat pump. Since I'm standing over a puddle of water, I won't be able to show what I'm doing, but it's pretty easy. I'm just pretty much gonna go wire for wire. I'm gonna take that wire out of the old one and put it there, and on and on and on all the way across. That's pretty much it. Alright, got the new defrost board in there. Just got one more wire. The DF2. This is the old one. See that burn mark right there? That's how I know it was the board. Didn't have to break out the meter or nothing. Plus, process of elimination. You know, the capacitor wasn't that low on the fan. The fan should have been running if it was the capacitor, just not the compressor. The compressor was at 22 microfarads. Should have been 45. and the fan was like 4.6, I believe, so the fan should have been running. I gulped a little bit when I saw that good number. I was like, oh, it could be low, but it wasn't. And the contactor is pushed in, and I have 240, so everything else was looking good but the board. So process of elimination is how I did that. All right, let's see what we got here. Come on, big money, no whammy. This disconnect's tricky. Oh yeah, moving some good heat out the top. Suction line's got sweat on it, nice and chilly. I'll check the charge whenever the water dries up. It's kind of hard working in a big puddle. I'll put the cover on, drive on to the next adventure. Burnt circuit board, look at that baby. We got a frozen Goodman air conditioner, frozen solid. They just left it running. I pulled the disconnect over here to shut the power off. Choke is frozen all the way through to the compressor, I think. Let's go see if the inside fan's running. Let's see what they got the T-stat set at. Set to cool and on auto. And I don't hear a fan. Whoa, that choke is frozen up. Frozen solid. It's probably going to be a bad module in there. Bad fan module. Usually when you turn the fan from auto to on, it'll come on. Let's see if that'll happen. Usually, not always. Nope, not this time. We're gonna have to pop the cover on this thing. Let me pull the, or not pull the disconnect, but let me turn the breaker off so you don't get killed. This is for the air handler. I get a lot of homeowners that stop by the channel and say, hey, my Goodman's freezing up. What do you recommend? Homeowners, if it's anything past the filter, I'd say call your local HVAC tech, because you're getting into some pretty heavy troubleshooting. Anything past the filter, I mean, you're gonna need a voltmeter, possibly some refrigerant gauges and a can of refrigerant. I recommend just calling your local HVAC tech if it's anything past the filter. But the most common is low on refrigerant or freezing up due to airflow not moving over the coil due to a dirty filter, or in this case, fan motor's not working. Alright, all the screws are out. I can't take the filter out because it's frozen to the coil. Good Lord, look at that. Somebody call Rob Van Winkle. Where's Rob Van Winkle when you need him? If y'all don't get it, I'll let you Google that. Sometimes these switches will go out. So what I'm going to be testing here is the fan module. Just these two screws right here, we'll take it out. Alright, I adjusted my light a little closer so you can see. Let me pull it off. Once you get the two bolts out, it'll come right off. Unplug it from the harness. And now we're going to get our voltmeter and test these three holes here in the plug harness. You should get the same number when you put it on ohms. Put your meter on ohms and test in between all these. This is how you know if the motor's bad, this, or the module's bad, this. If you get the same numbers out of here and continuity, then just change the module and it should fire up. Let me go get my meter real quick. Alright, I got my voltmeter set to the horseshoe, which is the ohms signal. Put one lead into the far left and one lead in the far right. Let's see what we get. 20.5. 20.5. Now in the middle and the far right. .5. Now we'll set to continuity. And if it beeps between all of them, I think it's just going to be the module, not the whole motor. We got continuity between far left and middle. Continuity between far left and far right. Now middle and far right. We got continuity between all of them, so this is good. All you got to change out is that. Hallelujah. I'm going to be unplugging this because it's easier to do. Just want to show you real quick the top here. There's letters. C for common, L for load, G for green, and white for neutral. This is your high voltage coming in. This will be 120 or 240. In this case it's 120. And the bottom is your low voltage, the numbers 1, 2, 3, 4, 5. It's hard to see, but let's see if I can get it on camera. I don't know why they made it in white, the same color as the background. But yeah, the numbers are the low voltage on this style, and the letters are the high voltage. Take a picture, that's what I do. When you put the new one back in, you'll know. Alright, I got my new one here. If you took pictures, you shouldn't be worried. So green goes to G. I'll start there. The common on the high voltage, they got it as a brown. I know these wires are in the way, it's kind of tough to see. It's tight in here. This is what I'm saying for the homeowners that stop by. It's a bit complex. Anything other than a filter, I recommend you calling your local HVAC people. Sure, it might be expensive, but if you tear it up, it's going to be really expensive. White goes to neutral for the high voltage, and then the two wires on the bottom are low voltage. The gray went into 1, purple went into 2. Sorry for the shot. The wires in the way. There we go. That's the new one. Plug it back into the harness. Oh, real quick, like if you didn't get equal numbers in these 3 motor holes, the motor's bad, you'll need to change it out. And you did continuity and it beeped in this one and this one, but not this one and this one, change it out. You got a bad motor. And this goes back up in here. And then you just slide the 2 bolts in and you're done. Where's my bolts? There we go. Alright, I'll put the 2 bolts back in and we'll test it out. Alright, Brosephine. 2 bolts are in. New module's mounted. Let's see what we got. If we can get that fan to come on. We'll be in the building. Auto to on. There we go. We have spinach. It's going to help melt that ice too. Alright, it's all buttoned up. Fan's still running. I'm going to have to let that ice melt before I can go check the charge. We'll take a look at the old module though. Doesn't really give you any signs. There's no burn marks or nothing. Some commenters have said that you can buy a tool that will test the module, but I just do the motor test with my voltmeter in the 3 holes. But yeah, there's no burn marks or nothing. Alright, I'm gonna let this thing thaw out. Oh, there we go. Oh, Put you in a new filtro. Alright, bro, Cephas, I'm all hooked up. Just gotta get the air out of my lines. You don't want air getting in the system. It will turn your refrigerant into acid. It's always good practice to get the air out. Alright, we're gonna turn the system on, see where this thing's at. Alright, I turned the fan to auto and the air handler turned off. That's good. See if it turns back on. We'll leave it at 72. It's 77 in the apartment. See if we get fanage. Yep. I hear it firing back up. Alright, the condenser came on. It's blowing the correct way. Oof. Not looking good on the charge either. That'll freeze it up as well. See that saturation below 32? 32 is below freezing. So man, that had no fan inside and the doggone unit's low on refrigerant. See, this is what I'm talking about, homeowners. Just call your HVAC guy. I can't do this over comments and go back and forth with you. It's just too much for a homeowner to handle unless you're just really handy, you know. I'm gonna give this thing some juice. It's a TXV, so we got to get the subcool to 12. I'll be back. Alright, big dog. 12 degrees subcool, 17 degrees superheat, saturation's at 43. I like it. I'll leave it there. See what it's blowing out the vent. Alright, Skid, let's see what we got here. This is what I use because it's better than putting my hand up here. I get a lot of super techs who stop by and chat my butt because I use one of these. But I mean, after 20 years, you can just tell, you know, if it's in the low 40s, high 30s, look at that 39, you can just tell. A lot of people come by, oh, that doesn't do anything. I can tell it's blowing cold as a witch's booty. That's gonna be a success, big dog. All right, off to the next event. What's going on, Skid? We got a frozen AC here. It's an icer. The outside is running, but the inside is not. When the inside fan doesn't come on, it freezes up. That's one reason why it could freeze up. Also low refrigerant. Those are the most common issues with freezing up. And sometimes you can get a restriction. But a lot of people ask, what's the most common reason for AC freezing up? Low refrigerant or no airflow? When air doesn't flow over this coil, you get ice. As you can see the fan, I turned the fan to on the thermostat. Got the thermostat off. I'm gonna split it open, see what's going on. It's one of those modules. I could hear refrigerant moving through the coil from the condenser outside, so I know the outside's working. I could hear it, but there's no airflow moving through. Well, that joker's all frozen up. So what we're gonna do is we're gonna check the module here. Pull out the old meter. There's just 2 screws and it'll come off. Let's make sure we turn the breaker off. This one's for the air handler. No power. It's a fairly simple repair. If it's just the module. Now if it's the whole motor, I'm gonna have to order a motor and wait till it comes in. But it's usually just the module. 2 screws, pop it off, put the new one back on, put the wires on, and you're done. Just go wire for wire, just how the old one is hooked up. Easy peasy. Just gonna have to unplug it and get the old meter out. Now if you don't have a meter, you're just gonna be guessing. The plug is right here. pull that plug off. Oh, there we go. Now we test the plug. If it's got continuity between all three beep, it's good. And then I'm going to do ohms. If the ohms are the same through all three, it's good. That's how you know the module is bad. Alright, got the meter set to continuity. Means you hear some beeping. Alright, we'll do these two holes first. Terminals. Should beep. Okay, that's good. Now let's do the two outsides. That's good. And the middle and the other side. Good. So I think the motor's good. Let me switch it to ohms now. And we're going to want all the ohms to match the numbers. And if they match, we know the motor's good, and we just got to put in a new terminal, or I mean a module, excuse me. 20. That's 20. And that's 20. All terminals have 20 ohms, all three together. So we know the motor's good. Let's take this module out and put in our new one, and it'll run. Alright, changing out the module is real simple. It's kind of hard to see the numbers on the bottom. 1, 2, 3, 4, 5. That's your low voltage, your fan speed. So this gray one in the number 1 terminal here, that's your slower speed for heat. And the purple wire in the number 2 is faster speed for AC. Again, that's your low voltage, and the ones up top here, that's your high voltage. This is a 120 system, so the 120 comes in up here. Some are 240. If you had 240, it would come in at the top. But real easy, just go wire for wire, hook the new one up just like you would do the old one. Same numbers, same slot, everything. That's what I do. Hadn't had an issue in 2 years. And then don't forget to plug it back in with the plug there. And pull the wires off. Take pictures, write it down if you have to. Just don't forget what goes where. Testing the motor and seeing that it's good. It's kind of a process of elimination. I never learned how to test the modules. I think they make a tester. I don't have one. I just kind of use process of elimination. Hey, the motor's good, so must be the module. Try to use a little common sense. So the gray is for the fan speed and heat, which goes on 1. The purple is the fan speed for AC, which goes in the number 2. So, okay. White, the neutral. Kind of tight in here. White, neutral. Green on the ground, the G. The black wire goes to the load. And the common is brown on the top, high voltage. So the bottom numbers, low voltage. The top, the common, load, ground, and neutral is your high voltage. All right, the new one's ready to mount up and screw in. And don't forget to plug it in. Kind of tight for the camera. Hope I'm getting that on camera. Hand might be in the way. There we go. Screw it in, turn it on. Sometimes matching up these screw holes can be tricky. Gotta use a little patience. All right, I did the disconnect up here as well, just for extra safety. This is a Aquatherm heating, by the way, so it has the little low voltage switch here for the door. So I'll just push it in with my finger just to see if the fan works. And then I'll put the cover back on. Come on, big money, no whammy. There we go. I guess somebody bypassed the switch. Now it does this little thing where it programs itself. Don't panic when it stops. Do not panic. As you can hear, it's slowing down. And then it stops. For you new guys, don't panic. There we go. I panicked. I'm just telling you not to panic. I'm saving you from the panic. Good to go. Now we'll just let that ice melt and make sure it's blowing cold. It's cold here in Florida. I live in Tallahassee, which is North Florida. I call it fake Florida. It gets cold here. The high's like 63, which is cold for Floridians. And the lows at night is like high 40s. Alright, we got it all buttoned up. Let's make sure it comes on when we set the AC to on, to cool. It's 72 in here. Set it to 70. Yep, we have fanage. I can hear refrigerant moving through the lines. I can feel it. I just use this because it's better than my hand Super Techs. I don't know why this makes some of the Super Techs so mad in my comment section. Oh, that's not a real thing. It's not a real temperature. I know. It's just better than holding my hand up there, big dog. All right, 51, 50. It's gonna get down in the 40s. It's blowing colder than a witch's booty. That's it, easy fix. Just a bad module. Now they make a tool where you can plug it into here and see if the module is bad. You can get that if you want. There's no right or wrong way to do this, but I just use the process of elimination. Test the motor with the beep continuity and the ohms. And if the motor tests good, tells me that this is bad. That's how I do it. All right, see you on the next one. Late.